Howdy. In this video, we are going to begin our discussion of Venn diagrams. So I assume that you've seen Venn diagrams before coming to my IB class, but I'm gonna start at the beginning and make sure we're all on the same page. First thing that we don't always remember to do is that we need to really draw a box around things to indicate the universal set. Okay, so this is the world that we're living in. We'll make that box with it, and then we have set A and set B. And if I don't label things like down here, then we can assume here's A, here's B, and maybe I even said that in the directions. But it's a good idea to label A and B. You don't necessarily have to label the U for universal set, but it's implied that this is now the world we're living in. That's the universal set. So in this one, they're saying the universal set is a set of positive integers less than 16, where x is less than 16. So we're looking at the positive integers from 1, because 0 is not a positive integer, up to 15, because 16 would have to be equal. And then A are our even numbers, and B are the numbers divisible by 3. So what we want to do is we want to put the elements in their correct spot. So if I look at the first number, I'm going to do all the integers from 1 to 15. Even numbers go here, divisible numbers go numbers divisible by 3 go there. So 1 is not in either of those, it goes here. 2 is even. 3 is divisible by 3, but it's not even. 4 goes here. 5 is neither of those things. 6 goes here. Notice with 6, it's both an even number and it's divisible by 3. 7 would be here. 8 was somewhere in this region. 9 is over here. 10 is even. 11 is neither. 12 is both even and divisible by 3. 13 goes out here somewhere. 14 is in here. And then 15 is over here somewhere. So now what we've got... they say state the elements in this. I've got 1, 2, 3, 4, 5 elements that are just in A but nothing else. And I have 2 elements here and 1, 2, 3 elements that are just in B. 1, 2, 3, 4, 5. Okay, so state the elements that are in the intersection. So we want to know, where does A intersect with B? Well, that's the set that contains the elements 6 and 12. State the elements in A not union B. Okay, so it's anything that's not in A. I'm going to shade this just for the fun of it. So not in A is all of this. Okay, it's everything outside of that. But they say union B, so that means I've already got this part of B, but I also need this part. So if I try and put them in order for sake, I mean, you don't have to, but for sake of convenience, I have 1, I have 3, I have 5, I have 6, I have 7, I don't have 8, I have 9, I don't have 10, I have 11, I have 12, here's 13, I don't have 14, I do have 15. So that is the set of elements. I've named out all the elements that are in not A or in not, so this is the union with or in B. Okay, so now the next thing it says, tell me the number of elements. This in right here means number of elements in. This is A union B. Well, A union B is going to be anything that's in A or it's also in B. So I want to know how many things are inside that, or how many. Yeah, okay. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's 10 elements there. I can also check because I know that there's a total of 15. It's the integers from 1 to 15, counting both of them, counting 1 and 15. So there's 1, 2, 3, 4, 5 things that are not there. So 15 minus those 5 does give me that 10. That's a way to check. The next thing says A naught intersect B naught. Okay, so what does that mean? If that's A and B, they're saying find the number of elements in A naught intersect B naught. So A naught is going to be everything out here, but intersect, so it's going to be everything not in A. And then this is intersecting with everything that's not in B, which would be all of this. So basically what I need is everything that got shaded twice. Well, maybe I should use a different color. But what happens here, it becomes this region. This region, it's the intersection of A naught, which is all of the stuff that I've shaded green plus this part of B that's not in A. And then B naught is everything shaded green plus this part that's in A that's not in B. So I need to know where both things are true, and both things are true in the green region. So how many elements? Basically, they're saying how many elements are out here? Well, we already talked about that. There's 1, 2, 3, 4, 5 elements there. Okay, so next thing, they want us to label some of these regions down here. So the first one here, there's always more than one way to think through it. One way to think about it is that this is everything but, One way to think about it is it's B and then stuff that are not in A. So you could say A naught union B. Or I could have said B union A naught. Those would be the same idea. So it's everything that's in B, and in addition to that, it's everything that's not in A. Or, so these two are basically the same idea. I just wrote them in a different order. Or what I could say is that it's, I could say that it's not this shaded part right here. Okay, so now let's describe how do I find this shaded part. Well, this is the intersection of B naught and A. So I could say A intersect B naught gives me this. Okay, let me see if I can make that a little more clear. So if I want, did I do that wrong? No, I did not do it wrong. Okay, if B naught becomes all of this. Okay, I'm back in my classroom after, well, I haven't really worked in my classroom since March, and it is currently August, and my pens are running out of ink, but I think I'm going to make it through. Okay, so that is B naught, and then if I want to find the intersection where A intersects with that, then I want to find the part of A that's already been shaded. Okay, and so that's how I get this little crescent shape here. It's the parts inside of A that intersect with what is not inside B. So what we can say is that since this little piece right here is that A intersect B naught, then everything else would be the negation of that. So it could be, if this makes sense to you, fantastic. This is just another way that we could have said that. The next one, what I have right here, this is the intersection of, this is A naught intersecting with B. It's outside of A, but it has to be in B. Or what we could say is that it's A union B naught. Okay, A union, everything that's not in B, but it would give me the not shaded part, so then I can negate it to get the shaded part. The next one, the easiest thing to say about this is just A intersect B. I don't really want to come up with another way to say it. I'm sure I could. I'm not going to. This one's a little more complicated. Okay, so what I would do, this one's easy. This is either A naught intersect B naught. So it's all the things that are not in A and not in B. Or it's A union B would give me the not shaded part, so I have to do the negation of that. Okay, this one is more complicated. So what we can do is we can think of how do I define that piece and then how do I define that piece. Well, this piece is, it's A intersect what's not in B. Okay, and this piece becomes B intersected what's not in A, or A not intersect B. And so I want the union of those two things. Okay, so here's one way to describe that region. Another way to do it is to say, does that make, hopefully we're on board. Let me know if that didn't make sense to you. But I can identify this, I want this piece, and then I put them together. The other option would be to say, okay, what's the not shaded part? What's the white part? And then we can do the negation of that. Well, this outside part, you know what, I'm gonna use a different color. This outside part right here becomes, so I'm going to do a bigger bracket. This outside part becomes, my brain just stopped. Oh yeah, it's A naught intersect B naught. It's all the stuff that's not in A or in B, and that gives me this outer, which is right here, okay? Or I could have said, well, let's just go with this. And then I also want, so union, this middle part. Well, this middle part we just said was A intersect B. Okay, so this little piece right here is A intersect B. This little piece here is A naught intersect B naught, but I want, now what I've done is I've described all the not shaded part, okay? And so if I want the shaded part, I have to say the negation of that. So in this one, it's definitely complicated. It's either, your two options are to think of, how do I describe the not shaded part, then I'm going to negate it to get the shaded, or how do I describe the shaded part piece by piece and putting them together. So hopefully that makes sense. It definitely takes some practice. You kind of have to practice thinking through this, wrapping your head around it, and let me know if you have any struggles. Good luck. Go practice.